In this video, I'm going to go over this organic chemistry synthesis problem where we have this alkene in the reactant molecule and we have this cis alkene in the product molecule with extra carbon-carbon bonds. And we see that because this is specifically a cis alkene, we could do retrosynthesis and go backwards and say that that alkene came from an alkyne where we used Lindlar's catalyst, H2 Lindlar's catalyst, to make that cis alkene. Right? And now we see that this alkyne right here came from these two carbons of the original molecule because we can number our original molecule like this: 1, 2, 3, 4, 5, just to keep track of the carbon atoms. And we can see that those 5 carbon atoms that I just numbered are these 5 carbon atoms right here: 1, 2, 3, 4, 5, where we see that the alkyne is between atoms 4 and 5, So we know that we want to shift our double bond from 3 to 4 to 4 and 5 to eventually get to the alkyne somehow. And to do that, we're going to crawl our way towards this position by putting a good leaving group like bromine on the less sub position here, carbon 4, the anti-Markovnikov position. So to do that, we could do HBr with some peroxide like ROOR, which will add bromine to the less sub carbon, the anti-Markovnikov carbon, like this. Now once we have this, we can make a terminal alkyne right here because we see that this could have came from a SN2 reaction where this was an alkynyl anion nucleophile and this was an electrophilic primary halocane with a good leaving group like bromine. So we want to make a terminal alkyne here, but to do that we need to have an alkene, and we see that this alkene here is less substituted, so we are going to do that by doing a Hofmann E2 reaction with LDA or turbutoxide, for example. Now, once we have the Hofmann alkene, we can now do Br2CCl4 to add bromines on both carbons, which is going to then be converted into an alkynyl anion with NH2 minus in excess, right? Because it's going to do E2 reaction multiple times until it gets to this alkynyl anion right here, where we can go to here by doing an SN2 reaction where we add this primary halocane to get to this point, which will then do H2 Lindlar's catalyst and reduce this internal alkyne to this cis alkene right here, right? So I hope this was helpful, and if you want more help in organic chemistry or hang out with me, join my office hours in my Linktree.